Hello, and thank you for the opportunity to compete in this NTK Hackathon. So we know from epidemiological evidence that Alzheimer's disease, or AD, is characterized by divergence in three main biomarker domains, so-called ATN criteria of amyloid beta, phosphorylated tau, and neurodegeneration. We also know that 40% of AD risk is potentially modifiable, and in the absence of effective drug treatment, this presents an ideal opportunity for lifestyle modification and risk reduction. So using the ADDI Workbench and the EPAD dataset, we investigated a relationship between ATN biomarkers. Further, we investigated how the Livingston criteria related to ATN classification and may provide a potential avenue for risk reduction in clinical settings. We first curated the dataset. Using the R technical environment, we cleaned the medical history dataset from long to wide, created binary variables for available Livingston criteria, then merged this onto the pre-curated dataset. We found 10 out of the 12 Livingston variables were available in the EPAD dataset: education, hearing loss, TBI, hypertension, alcohol, obesity, smoking, depression, physical inactivity, and diabetes. We were unable to account for social isolation and air pollution due to data availability. I'll now switch over to the NTK analysis platform to show our results. We did not apply any filters, giving us a total of 2,737 participants, 55% female and 36% with at least one APOE4 allele. Between males and females, we saw significant differences in modifiable risk factors like obesity, depression, and exercise. We have split our results into three categories, A, T, and N. We used GLM package in R to conduct logistic regression with the individual ATN classification as a dependent variable. We used two models with the Livingston criteria as the independent variables. Model 1 was unadjusted, Model 2 was adjusted for known unmodifiable risk factors for AD, age, sex, and APOE4. For amyloid, we found no Livingston criteria was significantly associated with amyloid beta and cerebrospinal fluid. This remained after adjusting for covariates in Model 2, where only APOE4 presence was significant. For the T, we observed TBI, smoking, and obesity were significantly associated with phosphorylated tau. After adjusting for covariates, smoking and obesity remained significant, however, TBI was attenuated. Finally, for N, we found smoking, obesity, depression, and exercise were significantly associated with neurodegeneration. These results remained significant after adjusting for covariates. Splitting ATN into three categories and applying Livingston criteria to a logistic regression, we did not find any associations with amyloid beta. For phosphorylated tau, we found TBI, obesity, and smoking were significantly associated, and for neurodegeneration, we found TBI, obesity, smoking, and depression, and physical inactivity were significantly associated. So, what is the clinical utility of these findings? Well, we have two suggestions for use in clinical practice. Firstly, we know that modifiable risk factors display therapeutic potential and offer avenues for intervention in clinical practice. An individual could be shown their modifiable risk factor profile in an easy-to-interpret traffic light presentation, with red lights indicating adherence to a dementia risk behavior, such as high alcohol consumption or physical inactivity. Secondly, we know modifiable risk factors attribute approximately 40% of dementia risk, and that biomarkers present up to decades before clinical symptoms, such as cognitive deficits, emerge. This presents an ideal opportunity to intervene and suggest positive lifestyle modification to individuals at early stages in the disease onset, where individualized feedback can be provided. To illustrate this, we simulated EPAD data in our local R technical environment. ATN levels were based on distributions in the EPAD dataset. We classified based on ATN positive or negative criteria, then plotted the points in a 3D environment in the Plotly package for R. This allows for an individual to see their individual biomarker levels in relation to others and visualizes all ATN criteria in the same graphic, something that is currently not supported in NTK analysis. With this in mind, we envisage this platform providing great clinical utility for the modifiable risk factors for dementia. An individual could visualize their biomarker profile alongside known modifiable risk factors, with evidence-based recommendations provided for lifestyle modification to reduce their risk of Alzheimer's disease. So, to summarize, using the NTK curation and analysis platforms, we have shown how Livingston's modifiable risk factors are associated with ATN criteria. How 3D models present an ideal opportunity to visualize ATN criteria and would be very useful for providing a catalyst for lifestyle modification in clinical practice. Thank you for your attention.